Welcome to True Projects. In this video, we are going to explain about a project titled Mushroom Classification using the Transfer Learning. The project's introduction provides the information about mushrooms, emphasizing their classification as a type of fungus. It states that among the vast variety of mushroom species, approximately 25% are categorized as edible, meaning they can be safely eaten. On the other hand, about 50% of mushroom species are considerable inedible due to the factors such as taste, texture, or the potential to cause the digestive discomfort. Moreover, around 20% of mushrooms are identified as harmful or poisonous if consumed, leading to the severe health consequences, including to the organ failure or even death in extreme cases. Thus, accurately distinguishing between edible, inedible, and poisonous mushrooms is of the utmost importance. Furthermore, the introduction highlights that while some edible mushrooms may not be favorable, they offer the notable health benefits. Certain mushrooms are found to have the potential anti-cancer properties due to the specific compounds that inhibit the growth of cancer cells. Additionally, certain mushrooms are known for the ability to combat the infections and strengthen the immune system, which contribute to the overall health and well-being. The project's main goal is to employ the deep learning technique, particularly the convolutional neural network, to classify the mushroom into edible, inedible, and poisonous categories. The objective is to enhance the accuracy of mushroom classification through the application of the computer vision methods and data augmentation techniques. The project assesses the performance of several deep learning models, including VGG16, MobileNet, MobileNet V2, ResNet 50, Inception V3, Especian, DenseNet 169, ResNet 101, LENet, EfficientNet V2S, and CNN. Additionally, it evaluates the effectiveness of contrast enhancement method and improving the test accuracy. Ultimately, the study aimed to develop a dependable and efficient system for identifying the mushroom species with potential application in the food industry and medical research. These are the basic requirements that are needed to build this project. Software requirements are Python IDE with version of 3.7 or Anaconda 3.7 or Jupyter or Google Colab. Hardware requirements are operating system as Windows or Linux, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. To know the flow of the project, the first one is importing libraries. In this module, the necessary Python libraries and packages are imported. It includes the libraries for data manipulation, NumPy Pandas for visualization, Matplotlib and Seaborn, and the Flask for creating the web interface. And the second one is exploring the dataset. In this module, the dataset containing images of the mushrooms is loaded and explored. And the third one is image processing. Image processing techniques are applied in this module to pre-process the skin cancer images before feeding them into the deep learning model. This includes resizing the images to uniform size, normalization, and data augmentation to increase the diversity of the training data. And the fourth one is split the training and testing data. The data set is splitted and trained into the two forms. And the fifth one is build the model. Here, we use the different deep learning models, and first one is VGG16 as a deep convolutional neural network with 16 layers known for its simplicity and effectiveness. And the second one is MobileNet, and this is a lightweight and efficient deep learning model designed for mobile and embedded devices. It uses the depth-wise separable convolution to reduce the computation and model size while maintaining the accuracy. And the third one is MobileNet V2. Here it is an improved version of MobileNet designed to further optimize the performance on the mobile devices. It introduced inverted residual blocks and linear bottlenecks for better accuracy and efficiency. And the fourth one is ResNet 50. It's a part of ResNet family of deep learning model consisting of 50 layers. It uses the skip connection to address the vanishing gradient problem and allows training of the very deep networks. And then Inception V3 is also known as GoogleNet as a deep learning model with the Inception modules that uses the multiple filter sizes. It aims to capture the diverse feature patterns by using the 1133 and 55 convolutions in parallel. And the sixth one is Aspersion, is an extension of Inception V3 that replaces the standard convolution with depth-wise separable convolution. This modification improves the modal performance and efficiency. And the seventh one is DenseNet 169. Is a part of the DenseNet family known for its dense connectivity pattern between the layers. It encourages the features reuse and gradient flow throughout the network, leading to the efficient learning. And the eighth one is ResNet 101. Is another variant of the ResNet family with 101 layers, providing even more depth and capacity. And the ninth one is AlgiNet. Is one of the early convolutional neural network designed for handwritten digit recognition. It consists of the simple convolution and pooling layer and played a significant role in development of CNN. And then EfficientNet V2S is a part of EfficientNet family known for the automatically scaling the model's depth, width, and resolution. It achieves the state-of-art performance with fewer parameters compared to the other models. And the CNN is a convolutional neural network characterized by the convolutional layers that help capture local patterns and features in images. And the sixth one is training the model. Here, the deep learning models are trained using the training data. During training, the models learn to extract the features from the images and classify them into the appropriate categories. And the seventh one is user gives the input. A Flask web interface is used to allow the user to input an image of a mushroom they want to classify. The user uploads the image through the interface. And the eighth one is the given input is pre-processed for prediction. The user provided image is pre-processed using the same technique applied to the training data, ensuring it is suitable format for the model to make the prediction. And the ninth one is trained model is used for prediction. The pre-processed image is fed into the trained model. Each model makes a prediction about the classification of the mushroom image as of edible, inedible, or poisonous. And the 10th one is final outcome is displayed. The prediction from the models are combined and displayed to the user through the Flask web interface, showing the classification of the mushroom image as edible, inedible, or poisonous. And the execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The dataset folder consisting of two folders, edible and inedible, were consisting of mushroom images within it. And the model folder consisting of H5 files which contain the algorithm information and it loaded at the time of project's execution and used it to perform the certain tasks such as of the making the prediction on the new data. And the sample folder consisting of different mushroom images that is used for testing the performance of the model. And the static folder consisting of the different CSS, JavaScript and Bootstrap files. And the template folder consisting of various HTML documents which contains of after home, index, notebook, sign-in and sign-up pages within it. And the app is an py file which contains the information related to the front-end logic. It includes the code written in Python that includes handle the server-side operation such as processing the user requests, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the notebook IPYNB file is a Jupyter notebook file which contains a combination of the code, graph and output all in once. It allows the user to make and write execute the code in individual cells, making it a popular choice for the data science. And the signup.db file appears to be the database file used to store the user information. First, we need to copy this address and open the Anaconda prompt for the execution of the project. And we need to select the disk, and my folder, this code folder is present in fdisk. That's why I'm writing the command as fdot. And here we need to write an command of cd space and paste the address of this folder and click on OK enter button. And we need to write another command of python space app.py where this is used of the command prompt will execute the Python script and perform a runtime check for any syntax errors or logical issues. And after running this app.py, the Flask framework will host the application locally at the default address as of this, and we need to copy this local link and provide it by the framework and paste it on any web browser. I likely prefer to use the Chrome, and paste it and click on enter button, and we get a screen like this, and this is the home screen and consisting of two buttons within it, and click on login button, and here we can see that we have the login and sign up buttons too. The sign up button is used to initiate the registration process. Clicking on it will take to the registration page where you can provide the necessary details to create a new account. But my account is already registered, so that's why I'm using the sign in page consisting of the username and password as entering of admin, and click on login button and redirected to this page consisting of home, notebook, sign out buttons with each consisting of different HTML files within it, and choose file and upload to. Click on choose file button. It redirected to this mushroom sample folder consisting of various mushroom images, and select any one of it and click on open button, and then click on upload button. Here the uploaded image is detected as edible mushroom, and use the try again button to get redirected this page, and choosing the other files to classify the mushroom, and selecting this one and click on open button, and then click on upload button, and it is predicted as inedible mushroom. And this way we can predict and classify the mushroom using the transfer learning. And this is the comparison graph where x-axis represents the algorithms we used and the y-axis represents the metrics value of the each algorithm, and each bar represents the each metric, where blue bar represents accuracy, orange bar represents recall, green bar represents precision, and red bar represents FN score. And in conclusion, the project concludes that deep learning approaches be effectively used for the classification of mushrooms, and found that using the contrast enhancing methods specifically improved the accuracy of the model. We suggest that the developer system can be used in the food industry and the medical research to identify the mushroom species accurately and efficiently. The project also highlights the importance of the large and the diverse data set for training the model and using the data augmentation technique to overcome the overfitting problem.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.